line by line. There's a JavaScript call that says, give me a line, give me a line. And then they call it tokenizing, and it'll create these name value pairs. So like the first sentence might say, a dark day indeed. And what it's going to do is the JavaScript in the mapper class is going to chop that up into A1. And what it is, it's the word A, and a count is I found it one time, okay? And then when it moves on to the combiner class, it's going to go through and look for any that are the same, and if the same thing appeared twice, it would combine them and change the number to a 2. That would be the combining phase. And I think I made up an example here where that happens. So this one says, day started as a good day indeed, and notice that day showed up twice. So the original mapper counted that one twice and created that key value pair as a 2. Okay. And then I guess that's the only example I have. And then the other one has a sentence, and it found indeed twice, and that's all. Okay, so that's the end. Each node processed all its data, made these little pairs, and then it combined any that were the same, and then it sends all 3 of them to the reducer class, and the reducer class runs the same thing this does, which it just goes and looks and it says, oh, I've got 4 days and 3 indeeds. What do I got? 2 indeeds there, and I must have another indeed over here. Yeah,
4
so
indeeds.
I got 3 indeeds, and so that's what it does. So you'll see that we will take.
It should be 4 indeeds.
Is it, so there's a bug in my PowerPoint.
Yeah.
Okay. Oh yeah, there's an indeed over there. So this indeed should be 4. Hopefully the Java code executes better than I did with my eyeballs. So we're going to take thousands and thousands and thousands of words, and again, we're only taking 3 books. If we were taking 300 books, then we'd want to have a whole bunch of nodes. And all the nodes will do this counting, and then they'll do this combining, and then they'll, when they're done, what you sort of don't see here is they sort of imply it like running on 3 nodes, but what really is happening is the host machine will split up the job across as many machines as it has. They will each run the mapper class on the piece of data they were given. We might take the book, for instance, and split it into 3 chunks. And then, because there's a combiner class, I think the combiner class by definition runs on the same node, or at a minimum, at least it runs on the output of that file. Now it's conceivable this, when it's done, writes that as a file, and then another node could actually run the combiner on it. And then, so you wind up with these files appearing all over the place with partial results. And then the Hadoop job's keeping track of all this. And then when it's got them all done, it moves on to the reducing class, and it'll assign the job of reducing to like 10 nodes, and it'll give them a set of files, and each of them will take a couple of the files and merge these numbers together like this. And then eventually, at some point, somebody needs to take the 10 files that will result from these 10 machines and do the final reduction to 1 file. So does that make sense what we're actually going to be doing? We're just counting words, and then, so now we've got to look at some JavaScript code. And the JavaScript code, which we have the source for it in our virtual machine, it starts with this jar archive package, and it has a bunch of example Hadoop programs. And you'll see when we actually run our Hadoop program, like you will give it as one of the parameters, the name of the Hadoop program, we will point it right to this jar. You don't even have to take it out of the jar. You can point right into the jar and grab this particular program that somebody wrote 100 years ago. In the JavaScript is this class string tokenizer, and it's the guy that breaks up the substrings, and it takes any sentence and turns it into basically I would call an array of words. So that's just a feature of the JavaScript language. So you can see it says string tokenizer, ST. We're creating this new object, string tokenizer, and we're giving it a piece of data. This is a test. And then we're doing a while loop. While it has more tokens, and then it's going to write out each one that it found. So that's the Java language has string manipulation that makes this really easy to do. We could do it in C# as well. The source code, if we actually look at it, starts off with what we would call using statements in C#. Here they're import, we're bringing in all these libraries. Okay. Up there we're bringing in this Java utility string tokenizer. We're bringing that in, so that's like dragging in a .NET library because it's something in the Java library that we want to use. We're using IO exception. There's a package we're bringing in, we're pointing it to the Apache Hadoop examples because that's where we're going to get this code from. And these, MapReduce, generic option parser, input, output, MapReduce, those are chunks of code that came when we installed Hadoop. So you're bringing in all these libraries you need to run it. And then you have to write, what do you want the map phase to do? So you express that by writing an object, just like you'd write an object in C#, only this happens to be a Java object. And it looks kind of similar, doesn't it? Public class word count, that looks the same as C#. And then it uses, it has this mapper guy, and private file static, write one new writable, private text or word, new text, object. So this is interesting. This is map. This would be one of those Hadoop libraries that we just added using. And then in order to make it do its thing, we give it an object key, a text value, some context, tell it what to do if it's upset. And then we're inserting the string tokenized value. And fundamentally, we're telling that mapper how to take lines of text and split them into those key value pairs. When you read the file, Hadoop automatically sees the carriage returns and it treats each line as a new line. You don't have to have overtly split it. So all we have to overtly split is the words within the line. And it outputs this thing they call a datagram, which is a string int, which is that pointer we saw, some word one, interesting one. Processes one line at a time as specified by text, and then splits the line token separated by white spaces, and we wind up with a bunch of those.
So what about hyphenated words? Does it still work?
Yeah, I imagine it treats it as a word because it's using white space as the break. And then, not all Hadoop programs, but this one does. You would always use a combiner if it would be like really efficient. If there's another step that it can go on and do to take its own local results and further process them. So our mappers spread it all out, and we have all these little tuples, and now it's going to, like, each node will say, I'll put them back together for the ones that match. And again, it's going to use the same one as the reducer. So it's going to do that local combine. So we have to define this class, our reducer class, and it's inheriting from the Hadoop. So we're picking up by inheriting from the Hadoop reducer class. We have all the built-in methods that the Hadoop reducer has. And here's a method reduce, which I suspect we got from the parent, and you pass in a key and some context and tell it what exceptions to throw, and then you're keeping track of a sum, and then for int writable values, you're adding it up, and then you write a key to the result. So you can, I don't know the magic of this, but you can see what it's showing is for any word that it finds, it's counting up how many it found. For however many it found, it writes that number here. So if it found indeed 4 times, it's going to put a 4 there, and it's going to put indeed there. And then the third phase, the reducer, which is going to do the same thing as the combiner, it gets these collections of datagrams, which are all stored in files all over the place. And instead of being a whole bunch of ones, presumably lots of them will be 2s and 10s and 20s, and it'll be add them all up. And then it's going to, the sorting process, and that's that's like one of the added values of Hadoop, which is if I gave you this long file with all those words with counts on them, how would you go through them all, sort them all, and combine them back together again to get grand totals, right? Well, you don't have to do that. You use the built-in methods. And if you were going to become a true Hadoop Java programmer, you would learn these methods and what they do for you. And we're going to do something that's not quite that hard. We're going to use this pig language, which will express exactly the same concept, but not in, it's sort of like a high-level language to express the same concept of combining things into sets. And then I'm literally, these PowerPoints, I took the source code that we're about to run and just chunked it into PowerPoint, right? So those other things were class definitions above that were required. And now we're down to our good old friend, public static void main. Have you ever seen that before? Looks like a Windows program, a console program. And configuration, strings, blah, 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 system usage word count. So we're going to have a new job. We're going to use this word count class. We're going to use this tokenizer mapper. This is the mapper we defined. This is the reducer we find. And remember, we defined that class. We're telling the job that your combiner class is that class that we just defined, and then we're telling the reducer, use exactly the same class. And then again, we're using the built-in, it's going to go through and map them all, shove them in one thing for us, and then it's going to write the file out for us, and we'll see what the answer is. This is a slide that says if you want to think about more about Java, how it's different, how it's the same. Like I said, for your homework, I'm going to ask you to, we'll look at these examples in a minute, figure out how to do what we're about to do, and basically give it different data and put in a different JavaScript file, okay? Now, the examples, just like we're going to run this example, we're not going to write any Java code. We're going to use the word count program that's already written in Java on a particular set of data. So what you'll do is pick another one of these libraries and use that already written JavaScript code to do something. And this is probably where they were, but that other document that text document, I put the real address in. Worst comes to worst, you should be able to poke around and find it, because it's going to be in user local Hadoop, which is where everything got installed. And then underneath of it, you might find several layers of directories. Oh, here's the examples. I want to come back to that later. So let's get out of that. So that's what we're about to do. Now, okay, so now what we're going to do is we want to get those Hadoop input files, those 3 books, over into the Hadoop file system. So you might think, I'm on the same computer on the same disk, but they're different file systems, which means they will take the bits and they'll store them completely differently in terms of how they're accessed. Okay. So what we're going to do is we're going to open up an LX terminal, log it in as HD user, and then you're going to go to user local Hadoop bin if you're not already there. Start up Hadoop if you didn't already. I don't really think you need to be in the bin, as I just saw, you just have to be in Hadoop. We're going to create needed directories inside of the HDF file system. Because we're going to copy stuff into that file system, there needs to be directories there to do it to. And this looks like a pain, but every time you want to run a Hadoop file system command, you will type Hadoop DFS. And then you'll tell it to do something, like if you want it to show the files, you'll say ls, but everything will have a -ls because it's not really a command, it's a parameter to the DFS command. So we'll see that in a moment. And then, I don't know if this is still true, but we probably, every time we get a command, it'll complain, it'll say, I don't have the native ones, I had to fall back and use the JavaScript classes. Well, that's the way it is, we can ignore that. So, what we want to do with these three commands, you know what? This class started at 3, right? What I'm going to do is I'm going to copy these into a text document and then put them back up on Canvas so that you can cut and paste and don't have to apply to that. There's not too many more commands, but we're going to type these commands to make the directories, and then we're going to copy some stuff up, and then we're going to run it. So it'll take us probably 10 minutes to actually run the job. But why don't you take a break while I copy this stuff in. I'll run Hadoop. It has a bunch of stuff, so we can just cut and paste.
Nice glasses. Nice glasses.
I guess technically I could open up the Word document in the browser on Canvas.
You get new ones.
So I downloaded that, I put it on my desktop.
We want ebooks are 10.
Say that again?
We want ebooks at 10.
So that was called Run Hadoop?
Yeah, it's called Run Hadoop Context. And the beginning of it has some junk. And then if you scroll down, you'll see those books and the book links. And then eventually, after the books, you'll get to where we are right now in the Word document, which is we're going to do these commands to make directories, and then we're going to copy the books over.
That command including the word bin. Usually that is the start.
I think you're in the directory bin Hadoop, and then you're typing the command dfs space dash.
You're in directory bin and you're typing Hadoop.
Yeah, I'm sorry, you're right. We're in bin, and we're typing Hadoop space dfs space.
Okay.
So, actually, if you separate these, it'll be easier to cut and paste.
So we are supposed to be in the bin folder?
Yeah. So over here, if you're in Hadoop, go down one level to,
Pretty normal to get the error, warn utility native code loader, unable to load native Hadoop library for your platform.
Yes.
Use built-in Java classes where applicable.
let me see.
Yeah, it says in the instructions.
Yeah. This is the thing where, so try to make a directory and it says, oh, you're not supposed to do that.